Okay, students. So what I want to do now is I want to introduce a new function. And that function, P and K, is going to be the number of possible ways K numbers can sum to n. And we're assuming that we're in the positive integers when we're doing this. We're not including zeros and negative. Otherwise, you get, infinity. You can have, if you wanted to get to 3, you could get 3 and 0, or 4 and -1, or 5 and -2. That wouldn't make any sense. That would be a silly definition. So, the numbers, we're not making them distinguishable or anything. We just want to know the number of ways that K numbers can sum to n. So we could always list them in increasing order, or at least non-decreasing order. So, for example, let's say I wanted P, I don't want 3. 3 is too small, but I already started writing 3. Let's do 5, 2. So this is the number of ways we can find two numbers that sum to 5. So let's see. Well, I could do 1 plus 4, or I could do 2 plus 3. And that's it, because 3 plus 2 is the same as 2 plus 3, and 1 plus 4 is the same as 4 plus 1. We're not taking any order into account in the numbers. It's just the number of ways we can find numbers that sum to n. So we can always list them in at least non-decreasing order. For P, let's say 6, 3. Okay, so I can do 1 plus 1 plus 4. And already we have to be a little bit careful here, right? If I do a 1 plus 2, I could get plus 3. I can do 2 plus 2 plus 2. But if I'm listing them in increasing order, I can't go 1 plus 3 plus something, because the other thing would be 2, and I already have 1 plus 2 plus 3. So listing them in increasing, or at least non-decreasing order, increasing but not strictly increasing order, that's a nice way to put it. Listing them in that order helps me not accidentally double count things. So now let's try and do P7, 3. Okay, so I could have 1 plus 1 plus 5, 1 plus 2 plus 4, 1 plus 3 plus 3. And those are all the ways that I could start with 1. Okay, so now I could have 2 plus, well, non-decreasing, so let's do 2, 1, 2, 3, 4, 5, 6, 7. And that's it, because if I try and do 2 plus 3, I'm stuck. I'd get the 2 and a 3 and a 2. I've already listed that. If I try to start with a 3, well, I'm in trouble there, because I'm going to have like a 3 and a 1, or a 2 and a 2. If I start with a 4, it gets worse. I have to have a 2 and a 1. So this is it. So P7, 3 is 4. That's what we saw. P6, 3 is 3. P5, 2 is 2. And the numbers increase by 1 every time. That's totally coincidence. I didn't decide which examples I was going to do ahead of time. But this is the partition function. The number of ways we can find K numbers that sum to n is P and K. And this is a really important function in discrete mathematics. It's a really important function in all sorts of fields. It's essential in number theory. Ramanujan studied this extensively. Partitions. It's important in group theory with group representations. It's just all over the place in mathematics, partitions. And this is, I guess, a very first introduction where we're just trying to see what this means. If anyone ever played Kokoro, you'll know that partitions are important, though in those I believe they're distinct. It's a game. It's a little, it's not quite like Sudoku, but it's on those, in that genre of paper puzzles as well. If you want to see some partitions. Lots of puzzles involve partitions as well. Okay. So that is the partition function. One more time, P and K is the number of ways that you can have K numbers, and not ordered numbers, just K numbers, which sum to n. And that is going to come up and be very useful moving forward.